We have to use mic or
no, no, we don't.
Okay. Okay.
Do you want to have a 5-minute break in between?
Yeah, sure,
Okay,
sure.
okay.
Okay, guys, so since it's Berkeley time, we will start the lecture. So today it is lecture 6, and it is the third part of the JavaScript lecture. So I'll be teaching the first half of the lecture, and my partner Josh will teach the rest. Okay, so the first part of today's lecture is on functions. I know you guys already learned about the functions in the last week's lecture, I believe, but just to give you guys a brief overview, functions is a set of statements that do certain tasks or calculate some values. And there are mainly 2 types of functions in JavaScript. The first one is regular function, is the one that we already learned about. And the second one is called the arrow function. So let me show you guys how these 2 works in the demo. Wait, how do I go to the demo page? So when we're defining a regular function, we first use a function keyword, right? Or I will just give you guys like a minute to make your own JavaScript file, and then I'll start the demo then. So if you want to follow along, you can make your own script.js right now. Okay, so I think that must have been an enough time. So when we are declaring a function or defining a function, we first use the keyword function, and then we will write the name of the function. So let's say we want to call our function greet for now, and then we will write the parentheses here. And this part will be taking the parameters into the function. But for now, our function greet will not be taking any parameters, so we'll leave it blank. And after that, we will write the curly braces. And inside these curly braces, we'll write down the body of the function, or basically the logic of the function. So yeah, and the logic for our function greet would be console.log, and it will print out hello world. And since this is a statement, we want to end it in a semicolon. But note that when you're defining a regular function, you don't want to end this here with a semicolon. We won't be doing that. This is different from defining a variable. So this is our regular function. And in order to actually execute the code, we want to call this function, right? And the way we call this function would be writing down the name of the function greet and then parentheses. And since calling our function is a statement, we will end it with a semicolon. If we save this and run our code, we see that the hello world gets printed out as we expected. So this is what we already learned. It is like defining a function with like a regular function. But now we will implement this exact same function in a different way. And that is what arrow function is. So if you have taken 61A by any chance, like the arrow function is similar to lambda function because it makes our defining the function much simpler. So, and when we are making an arrow function, we will treat the function as if it's like a variable. So we will use either const, verb, or let. It's your choice to use any 3 of them, but I will use const here. So const, and then greet. we'll write the name of the function. And instead of the parentheses, we'll write the equal sign. And then we'll write the parentheses. So this is where the parameter goes in. And we will write down the arrow function next to the parentheses, which is basically equal sign and then the greater sign. This looks like an arrow. So this is why it is called arrow function. And then we will write the statement next to the arrow. But note that we only have one statement inside our body function, right? So in case when you have only one statement within the body, you can also skip these curly braces and just write this statement right next to the arrow. And when you're defining arrow function, you want to end it with a semicolon, unlike regular function. So let's erase our regular function. And if we call this grid our arrow function, we get the exact same result, hello world. So I would say that regular and arrow functions, they do not differ in a fundamental way. It's just a matter of our choice. So it's up to you which function you use as long as it works correctly. So that was all for the functions. So yeah, is there any questions so far? If not, I will move on to the next part. So the next part is about the scope. But before we really talk about the scope, why do we need this? Like, why do we have to care about this scope thing in the first place? So if you go to our demo, like Visual Studio Code, I will write down a simple function. I'll write down the simple code. So let's say we have a constant and then message, and its value is high. And if you do console.log message, like this is really a simple code. Like we can expect that the output will just like high gets printed on the console. So if we save this and run this, like we expected, we get this high printed out. But if I make only one change to this code, which is I will write curly braces and I will put this statement inside the curly braces like this. If I save this and run the code, suddenly it gives me the error saying message is not defined. And we only made one change. We only put this one statement inside the curly braces. And this is all about scoping. So basically, scope is determining where you can access certain variables or constant. So in this case, the scope of this constant message is limited to the block in which it is defined. So basically, you can access this message constant only inside these curly braces. And why do we need these curly braces? And the first example of using these curly braces would be the function, right? Like you just like learned before. So if you say like function start and then like parentheses, this is a function, right? And this constant message will be only accessible within this function. This code will still give me the error because it is trying to access the message variable outside of the function. So if we save this and run this, we get the same error saying the message is not defined. But if we erase this and try to console.log message inside the function, and we have to call the function to execute it. Now we see high gets printed out. The next example of using a curly braces would be if statement. So let's say we will add if statement inside this start function. So if, and since we don't really care about the condition right now, I will just write true. And if true, I will say constant another is equal to by. And we apply the same logic here. This another variable is only accessible within this if statement block. So if I try to access this another variable outside of this if block. So let's say console.log another, save this. And if I were to run this, we get this error that another is not defined. So even if this statement console.log another is inside the function start, it will give us the error because it is still outside of this if block. And the last example of using the curly braces or like the block of code would be the for loop or like loop in general. So let's say we have a for loop and then we have I as a counter variable. So we'll use let I equal to 0 and I will run this loop 5 times. So 5 is less than 5, I is less than 5, and I will increment I every time I go through the loop. If you do console.log I here, save this, and then I will erase the if block. If I save this and run this, you can see that I's value gets printed out. Because in this case, I, the variable I, is only accessible within this for loop. And I don't think I have to show this to you, but if you try to access I variable outside of this for loop, it will give us the error saying that I is not defined because it is outside of its scope. And the last thing I want to talk about is that, so let's say we have function start and I will do, and we have a function start already, and I will define another function called like function stop. And inside the function stop, I will declare a constant message. So it has the exact same name with the message inside this start function. So like constant message, and I will assign different values by. This is a totally valid JavaScript code. Even though we have two variables with the exact same name, because their scope is totally separated, it does not really matter. It won't give us any errors. If these two statements, const message equal hi and const message equal bye, if they were in the same block, then it would have errored out. But since they are in a separate block of code, they have a separate scope. So the JavaScript will know which message we are referring to. So for example, if you're trying to access message variable within this start function, it will use the value hi. And if you're trying to access the constant message within this stop function, then it will use the value by. So if we save this and run this, we see there is no errors coming out. And the last thing I want to talk about is, so what happens if we declare a variable outside of functions? So let's say we have a constant here and constant equals number, 1, semicolon. What will be the scope of this number be? So this constant number will be accessible from everywhere in the code, which means it has a global scope. So you can access this number constant within this start function, within this stop function, or just like outside of any function. So like console.log number here, it won't error out because it's in the same scope. Yeah, so that is all I have for scope. So just to summarize, we have two scopes in general. So global scope would be the scope where like each variable can be accessed from anywhere. And the local scope, we can kind of like divide it into two parts. The first one is the function scope, which means that it is only accessible within the same function. And the block scope will be like only accessible within curly braces or like if statement block, for example. So do you guys have any questions on scope so far? Oh, yeah.
So if you declare the variable outside a function, and then you declare that same variable inside the function, then will it override?
Oh, okay. That's a very good question. I will show you how that works. So to answer your question first, the local variable takes precedence over the global variable. So if I go to Visual Studio Code, so let's say we have a constant number here, which is already in the global scope. And let's say we have a constant number 2 here. And we want to console.log number inside the start function. I will erase the rest of the code. And if I run the start function here, if I run it, yeah, the 2 gets printed out. So like the local variable overrides the global variable. Any other questions?
Under this case, there's a constant number. So like if you check the value of the constant number within the global frame and within the function frame, they'll have different values.
Yeah. So if I do console.log number here and rerun it, we see 2 gets printed out and 1 gets printed out. And this one, to make sure, I will erase this. And if I run this, 1 gets printed out. Yeah. So inside the start function, like the constant number, its value will be 2, but it does not change the value of the global variable. Yeah, good question. Anyone else has any questions? If not, I will move on to the next part. So now we learned about scope, we can really learn about the difference between Verb, Let, and Const. So to start with, if you use Verb keyword, like this can be used either in global and local scope. So if you use Verb within the local scope, that means that, like you can access that within the same function, but you cannot access the variable outside of the function. Like that rule applies generally. However, like if you use var keyword within the global scope, then that means that you can access that constant or variable from anywhere in the code. And you can redeclare and update the value also. But the problem is, so if you can redeclare the variable, that might cause an issue because, so for example, if you accidentally declared a variable with the exact same name with the previously declared variable, that will change the value of the previously defined variable without the intention of doing so, right? And we might probably not want that. So that's why we have let and const. So let and const, they cannot be redeclared, but the difference is that let, the value can be updated, but for const, the value cannot be also updated. So once you set the value for const, you cannot change that value. That's why it's called constant in the first place. And for let and const, they are both block scoped, which means that if you define a variable within the if statement block, you cannot access that outside of the if statement block. Yeah, and do you guys have any questions?
So for let, for example, if I were to define something with a let in a function, and then I defined it in like I don't know, let's say a different function, would it not allow that? Because it can be updated, but it cannot be redeclared. Like if it has the same signature, or would it allow that because they're different blocks?
Because they're in the different blocks, it will be okay. This explanation is about when they are in the same block.
Okay.
Yeah.
Thank you.
Any other questions?
Is let like an abbreviation?
Sorry?
Is let an abbreviation?
Abbreviation?
Yeah, it's like variable stands for var stands for variable.
I'm not really sure, but I think let is just let. Yeah, so let I be, like something. Yeah. If no one has other questions, then I will move on. So the last thing I will talk about for today's lecture is this keyword. So this basically refers to the object that executes the current function. So we can consider two scenarios. So the first scenario is if the function is a part of an object, and if the function is part of an object, we call that method, right? So if the function is a method, this keyword refers to the object itself. But if you're in a general function and we are referring to this will mean window or global object. So I will show you guys how that works. So we are in, again, Visual Studio Code, and I will try to define an object called video. And inside the video, there is two attributes, I'll say. So there is like a title, and title is A. And it has a method called play. And play will console.log this. And if I were to run this method, I will use kind of like a dot notation. So like video.play and call this function and end it with a semicolon because it's a statement. If I save this and run this, you see that the object video gets printed out. So this refers to video. You see like there's like a title A and it has a method play. But let's say we have a general function. So we will use function keyword, and there's we will call this general function play video. And if I console.log this inside this general function and call this, it prints out the global object. Oops. If you can see it, like, yeah, global object. So depending on which function you're in, this refers to different types of objects. Do you guys have any questions on this keyword? Okay, good. Then Josh will do the rest of the lecture then. Oh, before then, we'll have 5 minutes break. Yeah. So we will restart the lecture on 7:07. Yeah, you guys can enjoy your break. Do you want to stop the recording and
Maybe
All right, everyone, it's time to resume lecture. And after this break, we're going to be continuing on with the topic of asynchronous JavaScript. So what exactly is asynchronous versus synchronous code? So we've talked through working with synchronous code all up until now, basically running one line of code in your editor one line at a time and having it execute sequentially. But as you may have thought of this before, there are some problems with this. Sometimes your code could take a very long time to run, or maybe just an indeterminate amount of time that you don't even know how long it's going to run, and you don't want your program to be hung up on that one line of code. And so asynchronous code tries to take care of this problem for you. So while synchronous code works one line at a time, asynchronous code can run multiple lines concurrently, and it will notify your program when the code is finished with the result. So once you execute a line, you will not forget the result. Your code will know to come back to it, and then you will be able to tell the program what to do with the result once it has been returned. And usually we see this asynchronous code when we work with fetching data from remote servers. And so this is an example of when we don't know how long it's going to take for the data to reach our local machine. So we try to use asynchronous code to make our lives easier. And one way we can implement asynchronous code into our own projects is with callbacks. So what are callbacks? We use callback functions in order to implement asynchronous code. So these are used to make a callback to asynchronous code when they're finished, as per the name. And so these callback functions are additional arguments that we use for asynchronous functions or functions that are taking a long time to run. We want to come back to the result when it's finished. We use this callback function. And in addition, sometimes the process in which we're doing might take multiple asynchronous functions. You might want to chain your code in some way for your project, and it is possible to do this using nested callbacks. So we can chain asynchronous code. And so one example of a callback function is here. Set timeout is, I think, a built-in method for JavaScript. It basically just does something after a set amount of time. In this case, you can see set timeout has been called on this arrow function with the parameter of 500 milliseconds. So basically, after 500 milliseconds, it will do this function. And this arrow function basically just console.logs tick. We know probably what that will do for our project. So pretty simple example, but yeah, this is just one way we can use callback functions. Here's another example that is a little bit more complex. We have our function fetch data. And here we see it takes in a username and a callback function. And the result we get from fetching the username, which fetch is the way that we can get data from like a remote source. And this is what I'm talking about, like when we're trying to fetch data from remote servers, we don't know how long it's going to take. This is going to be some kind of asynchronous code. So a result will be called from that or assigned from that, and then we use our callback on the result. And yeah, we can see in the second part, our function that we want to use is actually yet another callback function. It takes the response, which in this case, you can see is the result from the callback, passed into the callback, and then it will do some loading. It will load data on this process data. So this is just like a simple example of a doubly nested callback function. First, we fetch the data, and then we process the data, or I guess, yeah, and then we load the data. All right. Do we have any questions so far on callbacks? All right, cool. So while callbacks are one way that we can implement asynchronous code into our JavaScript projects, we can see another way using promises. And so why would we ever use promises over callbacks? So first, let's go over some disadvantages with callbacks. And maybe with the previous example, you were able to see that callbacks can get messy real quick. You know, you have all these nested functions, they're calling each other, you have to put them as parameters into each other, and it gets really messy, really hard to read, especially when you're debugging your code. Yeah, lots of nested functions can get hard on the eyes and hard on debugging. And so you can make your life easier with promises, which will try to make your code actually human readable. And we can see an example of that in a few slides. So what exactly are promises? They're just another way to write asynchronous code. Promises, basically the promise that your code will be resolved later, hence the name. And so they are basically an object in JavaScript that may produce a single value sometime in the future. And this is just based on like the uncertain nature of asynchronous code. You're letting it run and you don't really know what's going to happen at the very end, but it will be resolved sometime in the future. And your code will be able to sort of do something with this resolved value or deal with why it has not been resolved, such as like an error with your code. There are three possible states for a promise. It's either fulfilled, it's rejected, or it's pending. And you can also chain promises similar to callbacks, which makes it a great alternative because you have the same utility with promises versus callbacks. So here's an example of a promise that we have made. We have assigned an arrow function to this constant wait. Basically takes in a time and returns a promise with the constructor of promise, which I'll get through. And so this promise constructor takes in another function, and this function takes in two arguments, resolve, and it should take in also a reject parameter as well, and it will return, or at least it will execute some kind of callback function, or you can think of it as a callback function. And so basically calling wait for response promise will give you a promise that will call set timeout every time you do, or every time you want to use this promise. And so we've made it wait for 3,000 milliseconds, which is 3 seconds. And we can see that calling .then, or using .then on the promise, and passing in our two parameters, which are resolve and reject, we will be able to use this very simple set timeout function on 3,000 seconds. And yeah, so first I will make it clear that the first parameter is what to do when the promise is resolved. So this will execute if the promise is like has been executed, it has been returned, nothing has gone wrong with your code, and it will console.log hello. The second parameter will be when something has gone wrong. And so this is basically when your promise has been rejected. In this case, your set timeout function probably will not reject at all because it's not very complicated. There's no like server errors or anything probably going to happen. But in the case that this does happen, you do have another function that you can call, and it will console.log your error. And this is basically where you handle all your error, or catch all your errors and handle them there. And on the bottom, I have provided another way in order to sort of look at this. We can, instead of passing in two arguments to .then, we can just pass in the one argument for the resolve. And at the end, we can chain a .catch at the end. This basically catches all the errors that have happened during your call to the promise. And it will just allow you to put in another function similar to before on what to do when your when errors have been found with your promise. Are there any questions on, yes? Yeah.
Could you possibly explain this?
Right, okay. So we've assigned this constant wait to an arrow function. this arrow function takes in some parameter time and will return a promise. And so this promise is sort of constructed in this arrow function and returned. This time parameter is basically what we see here in the next line, wait on 3000. It just tells the set timeout function how long to wait every time it is called, essentially. So that's what's happening. Are there any other questions? Yeah.
So you don't need like any conditional statement for the response promise. So the first line it prints out hello, and the second line it prints out error. So,
Oh, I see. Okay. So I guess the status of the promise is like the condition, right? It won't print out both because it's not going to error and also be successful, right? One or the other will happen, and therefore it will choose one of the functions to execute. Makes sense. Okay. Any others? All right. So we've been talking about asynchronous code, but where exactly does asynchronous code happen or occur in our projects? And one way to implement asynchronous code is by using fetch. And so what is fetch? The fetch API allows for calling data from another API. It's basically just taking a URL, sending an HTTP request to it, and that HTTP request will return all the data from the API, and it's also returning a promise. So basically, you can think about it as querying like a remote server. Whatever the server may do, it might just give you back some user information or something like that. That is what's going to happen from the fetch API. Fetch API tries to get this data from a remote place. And so, okay, I'll have a demo that can just sort of describe how to use fetch in your projects. Let's see. All right. Okay, so let's see. Basically, I've just prepared a little bit of boilerplate HTML here. Nothing too fancy. I've just done the HTML5 and have a h1 tag called hello world. And I've made a script.js here, which is currently empty. All right. So we want to be able to use the, we're going to be working with the NASA APOD API, which will return an image based on, and some data based on the image of the day from NASA. So I will call this the NASA APOD, and I will link my script here. Okay. All right. Cool. Okay. So first, let's just double check that the script has been actually linked to the HTML file. If we run console.log hello world and we inspect our, okay, yes, we get, as expected, hello world is in our console. All right, good. Now we can move on to actually implementing this fetch. Right, okay. And for anyone who else wants, anyone else who wants to like work along, this is easily accessible. All we have to do is go to NASA or api.nasa.gov. And this is the sort of like the endpoint in which we want to query to get data back from. So in order to use their APIs, NASA has like, I guess some sort of security feature. You need to generate your own API key. Don't worry about what this means too much. We'll probably go over like API keys and stuff. But basically, when you're sending your fetch request, NASA wants to know if it's coming from like, not coming from someone who's spamming their API. So you attach some data to your fetch request. This is going to be your API key, and they can verify it and say that you're not a bot or something like that. And so they give you the fetch HTTP URL for APOD already in this example. So you can just copy this, and we can use this in our fetch request. All right. So okay. So this is our fetch request. Right. And I guess first of all, in our HTML file, we want to be able to see this image. So let's set up a sort of a dummy IMG tag in which we will put our new image in once we get it back from NASA. So and I'll assign it like an ID. This basically lets us know, or from the JavaScript, like we can specify which element we want to take from the HTML based on their ID. And this is just like a specifier for this image tag because we want to be able to access it from our JavaScript file when we're putting the image data within it. So let's just call it APOD. All right, now, yeah, sure. Yeah, sure. And moving like forward, like through our JavaScript, we want to be able to access this element, like I said before. So in order to do that, on our JavaScript page, is it good? All right. We can use something called document.getElementsById. It might pop up for you. This basically is what I was talking about before. Our ID is like our specific selector for elements on the page. So by getting element by ID, we can specify which one we want. I think I called it APOD. So there, we have a reference to this element. All right. Since fetch returns a promise, we can do .then on it to sort of chain what happens after the API returns the data. And so sort of as a cleaning process, we want to take this response from NASA and turn it into a format that we can readily access. This is just done normally with response to JSON, make into a JSON object. Very easy to work with our JavaScript code. And so this in itself can be a one.then statement because we can chain them. And so between .then statements, basically what is returned from one of them will be passed into the next one. So we can just chain them like this. What is being taken into this is some data. And for now, let's just console.log it, see if this works, and that we are actually getting something back from NASA's API. I guess I'll add an alt tag so we can see this on our HTML file. All right, cool. And we see that in our console, we actually have gotten some information. It's a JavaScript object. And we see that within it, there's like a bunch of different data, such as like the copyright, who's taking the photo, the data, the date in which it was taken. There's an explanation, some image URLs, and so on. And so what we are interested in right now is trying to be able to put this image onto our page. So we want the URL from this data. So if we go back to our script, we know that there's some attribute URL on this object. And from like JavaScript 1 lecture, we know that we can just access this with our dot notation. And so I guess just to check that we got the URL, we can just console.log it. There we go. It's just a URL this time. We can do something with it. Put this on our put this in our image tag. And the way to do this is by once again referencing this photo element that we have made from the very beginning. So we want to set an attribute on our photo element, basically this image tag. And the way to do this is just calling the dot set attribute method on this element. This will be able to let us be able to modify attributes of our image. The attribute that we want to modify is the source attribute, because we don't currently have a source, which is why nothing is showing up on our HTML page. But now that we know what the URL is, we can just modify source and put in data.url. And so, yes, I'll keep this in our console, but essentially we're just setting the attribute source to data.url, and hopefully this will make us be able to see this picture on our HTML page. So if we reload the site, we see that indeed we get the image that we want onto our HTML page. Right, okay. I guess this is not all that we can do. If we look into our HTML page in the console, there's definitely other data that we can try to pull from this. One of which is like the explanation and the title. So we want to know what exactly is this that we're looking at on our page, and sort of why are we looking at this? So going back to our HTML, we can do this pretty easily by just putting in some more tags that we want to store the information in. Let's do like a p tag and an h2 tag. And once again, we want to make an ID so that we can readily access them with our JavaScript. So I guess this one will be title, and this one can be body. Going back up here, we need to actually have references to these elements. So it's very simple. All we got to do is change the element ID that we're trying to get. One of them is title, and one of them is body. Body. Right. Okay. And then down here, we just reference them down here as well. So now this is a little bit different. There's no attribute for like p tags or h2 tags that have the value of the text within them. So we're gonna have to try to use a different method, but luckily there still is a method in JavaScript which allows us to modify the inner text of a tag. And this is just the inner HTML method. So, or I guess this is an attribute. So we want to modify the attribute on this title element, and it's just inner HTML or just like inner text. So you want to set it to be equal to data dot, and let's see what the object has. So the title is just title, and I guess the body is the explanation. So title is data title, and body The body will be the explanation. All right. And so we see after refreshing our web page, we actually have also gotten this information, and we can put it onto our HTML, onto our HTML file from a fetch request. So I guess at this point, are there any questions, or does anyone want me to like show part of the code again? Yeah.
Yeah, can you scroll up a little bit just so you missed it? Okay. So my question is, in line 10,
Oh, sorry. Which line?
in line, well, line 9 now,
Okay.
for when you say data,
Right.
is that a placeholder referring to the fetch receipt, or is that the known quantity that's built in?
Right. Okay. So all of these .thens are basically just taking in arrow functions. So I guess maybe the spacing makes it a little bit more confusing to parse, but this is basically just one big arrow function, and data is just what I'm calling as the input. So I think I mentioned before, .thens can like return what they're working with after they're done. So when they return something, the next .then will take that return value as its input. So from before, we see that our first .then just basically returns a JSON. We want to take that JSON object and work with it. So we just, it's just piped into the next .then, and then I just call it data here. You can call it whatever you want, but it's basically just your parameter for your arrow function that you can then access later on when you're working with the code. Yeah. Right. It's right here. Sorry. Yeah, it's a bit hard to see at the very end, but yeah, it's basically at the very end of this fetch request is .then. It's the very next thing. Yeah, so the fetch request basically returns like some data. So after that, our first .then sort of tries to process this data, which is why we take in this response or the response from the API, and we just turn it into a JSON. And that's basically what the first .then is doing. It's nothing too special, but I think you'll run into this a lot. Once you pull data from an API, the first thing you probably want to do is turn it into a JSON so that you can work with it easier in the rest of your code. Are there any other clarifications? Oh, yes. Yeah, sure. Okay. Oh, and I guess one clarification that I might say is that you might want to put your script tag at the very end. This is because I guess how HTML and JavaScript are rendered. If you put it at the very beginning, you won't be able to reference any of these elements on the page because your HTML file sort of runs the script before it makes any of these things on the page. So if it tries to like access elements before they've been made, you'll not be able to access them later in your JavaScript. So yeah, it's best to put it at the very end, at least in this case, because you are referencing back to elements on the page. Right, okay. Are there any other questions? All right, cool. I guess we have more time at this moment. So I guess it is possible for us to sort of look at some of the other APIs just to like get a little bit of a taste of what you can be, I guess what you can be querying on the internet. NASA actually has a bunch of APIs that you can query. And if you just click any one of them, it has a very good description of what they are and sort of what they will return. And each one of them has their own HTTP request that you can just put into your into your fetch, and it will return some information. You will note that I think every single one of these requires some API key parameter. Basically, all you got to do is replace this API key with your own API key that you've got when you made your account, and you'll be able to access their data. And yeah, I guess we can do one more example with the images, because some of these don't return just images, and it's a little bit harder to work with like dense information that can be returned by these APIs. But yeah, these images probably can be easier to read through. So this is copy one of their fetch requests. Go back to our HTML. Sure. And we can just make another fetch request. Make sure to copy over your API key so that you can replace this demo key at the very end. Here I'm just doing the same thing as before, making sure it's in a JSON format with my first .then. And then afterwards, we can take the data that it returns. And for now, let's just console.log and see what's happening, what we're getting with this fetch request. And I'll stop. Right. Okay, so we can see with this new API route, it basically just returns a bunch of photos. There are a lot of photos. I think we can limit the amount of photos with another parameter in our fetch requests. And then once again, we'll just get into like what parameters are for fetch requests later. But oh shoot. But yeah, you can pass in more information for these APIs, and they'll be able to work with them on their own end. So let's see. And so I guess we can see that from our console, basically just returns an object with some attribute called photos, and this photos is an array. So we want to access these photos. And once again, now we just get this array of, I guess, objects. Let's just take like what, the 90th one, see if that works. And right now we see that the 90th image is just this. There's some information associated with it. And once again, we see that there's an image source, which we want to pull into our HTML file. So let's make another, I guess, actually first we need to make another image tag in our script. So we get the element by its ID. And then finally, we set attribute source to be data.photos, the 90th one. And returns an object which has image source with the URL. So access that real quick, save the file, and we can see yet another image on our web page. And so, yeah. I guess one thing you can you might have noticed is that these images sort of loaded in at different times. And that's sort of a result of asynchronous code, right? And before I mentioned that this code might take some indeterminate amount of time to run. And right now it's being pretty quick, but sometimes this request can take a couple seconds, maybe longer. And so I guess this demonstrates that it will be able to resolve what's happening once the promise has been fulfilled. So and yeah, it's able to render on our HTML page. All right, cool. And that's it for today's lecture. Are there any questions? All right, cool. And some announcements for this week. I guess project 1 is due today.